Now moving to the seventh question. So seventh question is given as dy by dx equals to something in numerator divided by something in denominator. So this is a very unique question, like very frequently asked question in UPSC. So the way to solve this problem is m dx plus n dy kind of format. So if we try to manipulate the given equation in the format of this one, it becomes something like this. So actually I have already written, just I am quoting what I did. So it becomes something like this. So m dx plus m dy equals to 0 becomes exact only if del m by del y equals to del n by dlx. So if we do partial differentiation of m with respect to y and n with respect to x, we get 6xy square, basically which shows that both LHS and RHS are equal. So this is the proof. This is in coherence with given formula that exact is valid here, and we can proceed with standard formula, working rule basically. So working rule is equals to m dx plus n m dx, where y should be constant while integrating m with respect to x, and terms in n not containing x dy equals to c. Fine. So m is, so let me erase and I will begin from here only. M dx, fine. So what we do is that m is 2xy cube plus 2xy cube, right? 2x plus y cube, ठीक है. 3x square y square. So there should be no any terms in n while integrating with y. So the only terms remain is this one. Fine. Good. So if we integrate this, it will become something like that: x square y cube plus 2x 884y divided by 4 plus equals to c. So this becomes the final solution that we are looking for. This becomes answer. Okay, moving ahead. This is related to Claret form. Reduce the equation to Claret form by substitution. This solve the equation, and also so that this is a singular solution of differential equation. So we know that Claret form is y is equals to px plus f of p, where general solution is given by y is equals to cx f of c, where c is in constant, where c is a constant. Fine. Okay, so we have to bring the verb equation, this wala equation, into this format. So we know that small p we write as dy by dx. Fine. Dy by dx, the p which is given here by notation, by standard notation, it means dy by dx, basically the differential. So now we have given y is equals to u and xy is equals to v. So now dv is equals to capital P. We say by notation that capital P is equals to dv by du. So now we calculate dv is equals to x dy plus y dx. Du is equals to dy. So this is 2. We write putting from 2, capital P is equals to x dy plus y dx plus dy. Capital P is equals to x y, then it becomes dx by dy. Dx by dy is nothing but 1 upon small p. Fine. This is our capital P. So we write it as p minus x is equals to y by p. Small p is equals to y by p minus x. This is our form that we need to get. Fine. And now we put small p into the given equation. Given equation is x square p square y 2x plus y p plus y square. I think I'm correct. Y into 2x plus y into 2x plus y into 2x plus y p. ठीक है. Okay, so this we need to solve. What here, like we simplify it, x square p square 2x y p plus y p y square I think this becomes square xy xp plus y square is equals to the whole square plus equals to fine, no, 2xy into p to y square. Fine. So fine, and now we replace these things, these. Okay, so xp from 1, like from here we can write it as this term would be capital P small p capital P small p का whole square y square small p. Fine. Then it becomes y square small p p square small p y square equals to 0 small p 0. ठीक है. So it's become like either p equals to 0 or capital P y square equals to 0. Fine. Now replacing small p square, replacing small p is y upon capital P minus x y square is to 0. Okay, so we simplify it. P square y p y square minus x y square. Fine. So we try to write in the form of u and v. So p square, I think it was y is equals to u. Y is equals to u, if I'm not correct. Yeah. U. This is u square minus ub, I guess. Okay. So v is equals to, we have taking this term into RHS. So this becomes pu p square, if I'm not correct, if I'm not wrong, sorry. Yeah, I think it's correct. Yeah, so this becomes a standard form, what we intend to get. So claret form, we get claret. This is claret form. CLARUT, clarets form. Claret. I think spelling is wrong. Claret. CLAIRO. Clarets form. Fine. So the general solution is just we have to replace p with some c, where c is some constant. So v's general solution is y. Sorry. No, solution is c u c square. Okay. So we know v is nothing but xy, u is nothing but y is equals to c. This is general solution. General solution of equation. Fine. So now we got the solution. We solved the equation. Now we have to show that like this term y plus 4x is singular solution of differential equation. So in order to show the singular solution, what we need to do is that we need to find C discriminant of the general solution. So the singular solution C discriminant of general solution is solution c square plus cy minus xy is b square minus 4ac equals to 0. Fine. So now again we separate it as y plus y 4x equals to 0. Either y equals to 0 or y equals to 4x plus 0. So we have to show that y plus 4x is singular solution of the given solution. So so since this is a term of discriminant, therefore it is a singular solution provided this equation also satisfies the given equation. Singular solution because it satisfies equation, given equation. How we can show that, like given equation. So we can show that, like take y is equals to 4x. So what you can do is that y equal to minus 4x, wherever there is y, or you just put x in terms of y or y in terms of x, and put p as nothing but dy by dx. The dy by dx is equals to, which is nothing but p, is small p, it is nothing but minus 4. So put this and this into the given equation and you will get the whole of the terms getting cancelled. So that's why this term y plus 4x is a general solution, or sorry, the singular solution of the given equation. So moving ahead, this is generally a topic, a question from Laplace transform is asked each year. So this is one of them. So the following initial value problem by Laplace transform technique is this. This given terms like y equals to 0 equals to y at x equals to 0 is 1, y dash at x equals to 0 is 0, and f dash t is a given function of t. So Laplace transform, like we need to know what is the Laplace transform of differentiation. So we know that Laplace transform of y double dash is nothing but d2y by dx square dt square, where where y double dash is nothing but d2y upon dt square. Similarly, y dash is equals to dy upon dt. So it's nothing but p square, where p is parameter in Laplace transform, p square, right? Laplace transform of y minus what happens is p y dash 0, I think it is y0, minus y dash 0. So the how can you can remember is that like this the power 2 is nothing but the order of differentiation, and this power is 1 less than the order. 1 less than this order is 2 is 1. So remember that like the its differentiation is order should be 1 less than the order. Like its power is 1, its power is p's power. I think I'm confusing it. Leave it. As you were whatever suits convenient to you, learn according to that. So L y double dash is equals to p square Ly minus y0 is nothing but 1, and y double dash is nothing but 0. So this becomes 0. y dash is equals to p Ly minus y0. y0 is nothing but 0. y0 is nothing but 1. Sorry. Similarly, what we did is like Ly double dash is equals to p Ly minus y0. Fine. So put these two into the given equation. This is 1, this is 2. Put 1 and 2 in equation. So what it becomes is p square Ly minus p minus 4 p Ly p of Laplace transform of y minus 1 plus 3y. Just I'm writing y of t as y f of t. So taking the p square terms into one side, p square is equals to L of y, this term okay. I'm doing anything wrong. Fine. So separating the terms, minus p I think it will be convenient to segregate as per the coefficient of Ly. P square minus 4 sorry here this will if we take a Laplace transform, this y will also be converted into Laplace transform of y. Fine. Since we are taking Laplace transform on the both side, this will also be converted to Laplace transform of t. We had left previously then. So it will become 3. So taking the terms of p to one side, p minus p plus 4 Laplace transform of f of t. Fine. So we have to solve for y. So why we did that? We have to solve for y. That's why we took segregated the terms of y at one side, LHS side, and t on the other side. So L of y, we segregate these terms into LHS and LY terms into LHS and the rest of the terms in RHS. F of t okay plus p minus 4 p minus 3 p minus 1 p minus 3 p minus 1. Why we did so, like we segregated terms? Because now in order to get y we will take Laplace inverse of transformation, Laplace transformation. So taking inverse both sides, this inverse of Laplace transform of y becomes y. Laplace transform of f of t, p minus 3, p minus 1, p minus 4, and p minus 3 minus 1. Now we know that Laplace transform of e of at is equals to p minus a. This also means that e of at is equals to e raised to the power 18 basically, means Laplace inverse of p minus a. So this identity will be using here. So y is equals to Laplace inverse of, here it is Laplace of f of t. Fine. Now we do that. What we do is that Laplace transform of f of t for one time, for sake of convenience, let's say like f of t is equals to is capital F of t. So Laplace transform, so y is equals to what we do is we factorize it, L inverse f of t, say f of p, because p will be in parameter of transformation. So f of p, so what we have to factorize, how we'll be doing. So I want to let you know that the trick is there. If we want to factorize, say this thing, 1 upon p minus 3, p minus 2, p minus 1, what you can do is that just put a p minus 3 plus b p minus 1. Okay, so what we can do is that in order to get a, what you have to do is that put coefficient, this term equals to 0. So basically if you equate this term equals to 0, you will get p as 1. So if you put p as 1 here, except this term, except the p minus 1 terms, so you will get as a is nothing but at p is equals to 1, exceeding, since we are putting p equals to 1, we will be excluding this term, p minus 1 term. So a becomes 1 minus 2. Similarly, sorry if I am doing wrong. Okay, I'm sorry. In order to get a, you have to put p equals to 3. Why? Because because you know, if we put p is equals to 3, multiply both side with p minus 3. So if we multiply p minus 3, this will cancel, and we will be here as p minus 3, and this will get cancelled. So this will get cancelled. So if you put p equals to 3, this will become 0, and whatever terms we will get here from here, that will be equivalent to a. Got it? So 1 minus p minus 1 is equals to a is equals to b p minus 3, but I'm just writing it for the sake of convenience so that you may understand. So if you put p minus 3 here, if you put p is equals to 3, a will get 1 by 2. Similarly, if we put a equals to 1, we will getting b will be nothing but minus half. So we got with very ease of convenience that p minus 1 is equals to half of 1 by p minus 3 minus p minus 1. Fine. This is the term that we got, and simplifying the now putting these terms into one, this is say a. Fine. And moving it from a, we get y is equals to Laplace inverse f of p, because we have assumed that Laplace transform of f of t is f of p. Fine. Now come again, moving ahead, like we can simplify it as p minus 4. P minus 4 can be written as p minus 3 minus 1, p minus 3, p minus 1. So y is equals to, I'll transform Laplace inverse f of p f of p minus 3 minus Laplace inverse f of p minus 1. Fine. Plus we'll be if we will try simplify it, we will be getting as p minus 1 minus, well, transform. So it will be similarly like previous term. It will become like this, p minus 1, because on the next side, on the other side, this wala term will become the previous term, like that we solved this one. So I'll transform by 2 f of p minus 3. I'll transform to f of p minus 1. This will become a Laplace inverse of p minus 1 is equals to e of t minus half of Laplace transform of 3t minus Laplace transform of t of t. I think we are okay with that. And in order to solve this, kind of when there is a function of through convolution theorem, convolution. So what happens that, like, if you want to convolute this equation, the general provided that f of p and g of p are integrable, like they are kind of Laplace integrable, Laplace transformable, double. I'm forgetting the name of the equation. Uh, let me check once. Yeah, a class A function has basically they are differentiable. I am forgetting the what should be the condition of class A. You may see in the theory. Uh, so provided that f of f of t f of t and g of t, basically just see the convolution theorem, you will get to know what is class A and how this equation, how this inverse applies. So it will be written something like this: g of integration limits from 0 to t f of x g of t minus x dx. So basically here f of x and g of x is nothing but, sorry, I think I should write it in small. Basically L inverse of f of p should be f of x, f of t say, and L inverse g of p is g of t. So we know that we have already mentioned that Laplace f of t is nothing but L inverse capital F of p. So from there we can say that this whole term can be written as L inverse f of p minus 3 is nothing but integration from 0 to t. Like f of t would be Laplace integration of f of capital F of p is small f t. Its Laplace integration of p minus 1 upon p minus 3 is nothing but e minus e 3t. Sorry, let me write here. Laplace inverse of f of p is equals to f of t. Laplace inverse of 1 upon p minus 3 is nothing but e of 3t. Fine. So using this one, so t3 in place of t will be writing t minus x dx. So it becomes something like that. This is the integration that we want. This is the Laplace transformation that we want. So finally we can write it as y is equals to 0 to t to 0 integration 0 to t f of t e 3t minus x dx. Similarly for this term we wrote this term. Similarly for this term also, since half was there, minus half integration 0 to t f of t e 3 e t minus 1, sorry, e t minus x dx. And if we simplify these terms, minus e की power 3t by half, if we simplify, then it will become half plus 3 by 2 e की power t. This will be final solution and hence will be answer. So we are done with all the questions. So my final take on all these questions is that, like, some questions are lengthy, like the Laplace transformation, Laplace through Laplace inverse is sometimes can be lengthy, like you have to do partial fraction, you have to do convolution. Sometimes it can be tricky, and there is a very high chance that there may be calculation error also. So while choosing these questions, you need to be careful, like you need to do very alert while solving these questions to avoid um calculation errors. These types of questions like are easy, where we have to solve for equation. So these types of questions are relatively easier, and there is less chance to do error, calculation error basically. So that's all. Thank you for